So last time we learned about what the trig ratios were. And what I mean by that is the sine and the cosine and the tangent of an angle. And so we learned about SOH. And so S-O-H, meant that the sine was opposite over hypotenuse. Cosine, the ka, was adjacent over hypotenuse, meaning the side that's next to it divided by the hypotenuse, and tangent, toa, was opposite over adjacent. And so what we're going to do now is we're going to use those sine, cosine, and tangent ratios, whichever one is most beneficial to us, to solve for missing sides. And so in my first question here, I've got a ladder leaning up against the side of a house. And I want to put that ladder at a safe distance so that when I get up on top that I don't accidentally hit something and then you go, oh, and the classic slapstick comedy of the person falling off the ladder, being stuck in midair, and things like that. So we want to put it at a safe distance. And so a lot of people say, in general, you want it no bigger than a 70-degree angle. So if I have a 20-foot ladder and I don't want it more than a 70-degree angle, how far away from the house should I put the bottom when I'm raising up the ladder? And so, if I'm talking about the 70-degree angle, and again, I have a house that is perpendicular to the ground, so we have a 90-degree angle, this x is adjacent to the 70-degree angle. And it is the 20, the hypotenuse, that is making up the ladder. And so we have the a and the h, and so the a and the h we use cosine. So I'm going to say cosine of this 70-degree angle is the ratio of the adjacent to the hypotenuse, which is 20. And we set up this equation. Now, to solve this equation, we want to get x by itself. And so what I'm going to do is I'm going to multiply by the 20 to cancel out the divided by 20. And so cosine of 70 gets multiplied by 20. And this is where you need your calculator. And so I'm going to grab my calculator. I'm going to hit 20 times the cosine of 70. Cosine button is right here, the sine, cosine, tangent. And that's what all those buttons are about. So 20 cosine of 70, I'm going to hit enter. Now I got 6.8. Seems fairly straightforward. If you got a different answer, you might want to double check that you are in degree mode. How I just got there is I hit this mode button right here. And make sure if maybe you have radian mode and you got the answer, you got the answer 12.6. That would be incorrect. We don't know about radians yet, but you will. But make sure that degree is highlighted, so you go down and hit enter to make sure it's highlighted. And then you can quit out of that and get the 6.8. And so that's 6.8, about 6.8 feet. And so if you wanted to play it safe, I would probably round up to 7 to make sure that you're far enough away from the house to make the ladder safe to use. So, next we have, I also wanted to real quick say that if you didn't want to use the 70, you could use the 20 up here. You could use the 20, and it changes your equation a little bit. Because then what happens is the x is all of a sudden not adjacent, but it's the opposite. And the opposite would be O and H, so I would use sine. And so you could also set it up with the sine, but now it's of the 20-degree angle. And so now x is the opposite. This was adjacent and hypotenuse. This is opposite and hypotenuse. And so then it turns into 20 times the sine of 20. And 20 times the sine of 20 should give us the exact same thing, 6.8. So that's why it doesn't matter. So in the next problem, we're pulling a wagon, and we've noticed that, somebody's got an arm attached to their head. we've noticed that we can pull it nicely at a 25-degree angle. Now we want to be pulling it at 20 newtons, which is a force unit, and you'll learn that as you get into physics. But the problem is we're going to pull at a slight angle because we're not going to bend down to pull it straight across. But we want to know at what force do we have to pull on the handle so that we get a forward motion of 20 newtons, forward force. And so based on this 25-degree angle, if you didn't get that whole explanation of force, it's okay, because we're going to focus in on this triangle. We want to find the hypotenuse of the triangle. It's across from the 90. And we have this 20 newtons, which is adjacent to the 25. And so adjacent and hypotenuse is cosine again. So cosine of 25. But now adjacent over hypotenuse is 20 over x. And so the different part here is that the x ends up on the bottom. And so what we're going to do is the same thing as we did last time, except we're going to multiply by the x to cancel out how it's divided. So multiply by the x, that crosses out over there. Got to multiply by x on this side as well. So then we end up with x times the cosine of 25 equals 20. And we're going to divide by this whole cosine of 25. Whole cosine of 25. And that's going to cross out the cosine of 25's. X equals 20 divided by the cosine of 25. And I'm going to type that into my calculator. 20 divided by cosine of 25. And that is approximately, I'm using the squiggly because it's approximately 22.1. And we're using 22.1 newtons. So if we want it to go at 20 newtons, get a horizontal force of 20 newtons, we need to pull it at 25 degrees with 22.1 newtons. And so we used cosine again. So when the denominator has the x in it, there's a little multiply it over and then divide. That will happen sometimes. Or the first time, we had the variable on top and you just simply had to multiply by the 20. Next problem. We have a telephone pole. We want to know how tall the telephone pole is. And if you've done any walking around your neighborhood, some of these telephone poles have these wires that hold it up straight to make sure that they don't fall over. Usually they're on the corners where they have to change directions. Otherwise they don't have that much support because they're buried deep into the ground. But so we've measured the distance from the bottom of the telephone pole to the corner of the base. And we also measured the angle that it makes with the ground, and we got that to be 75. So relative to the 75, the h is the opposite side. And the 9 is next to the 75, so we call that the adjacent side. Notice that this then is the hypotenuse. And so if I want A and O, opposite and adjacent, go back to SOHCAHTOA. SOHCAHTOA, O and A. I want the tangent. So tangent of the angle 75 is opposite over adjacent. And so I'm going to put x, and sorry, this is h in this case. So we made it h over 9. So that's opposite over adjacent. And so how you deal with that is you multiply by 9 to cancel out the divided by 9. Tangent of 75, h over 9, multiply by 9, because that crosses out the divided by 9. And then you get 9 times the tangent of 75, and you type that into your calculator. 9 times the tangent of 75 is 33.6. And so telephone pole is about 34 feet tall. And there you have it. This is how you use sine and cosine and tangent to find missing pieces within right triangles. Do not go about using these without right triangles. A few words of warning. After we use this calculator and we find out about this degree mode, it worries us that every other operation is going to be messed up. And so, isn't always the case, because the only time you need to worry about the mode is if you're using sine or cosine or tangent. Now, one extra thing that you'll have to know is, what if you're not given the angle? And what if you had the same telephone problem, or maybe you were looking for your 3, 4, 5 triangle, and I wanted to prove to you that 3, 4, 5 is not the same as a 30, 60, 90 triangle. One of which it doesn't have the same ratios. But I wanted to show you what this angle was right here. And so I don't know what the angle is, but I could use the 3 and the 4 to my advantage. Relative to the angle, 3 is the opposite side, and 4 is the adjacent side. And so that's O and A, so that is tangent. So I have the tangent, but I don't know the angle, so I'm just going to put theta. And so tangent of some angle is opposite 3 over adjacent 4. This is what I want to find. So I want to get the theta by itself. I want to find the angle. So to free it from the tangent is a little different, because if you were solving an equation like x plus 4 equals 10, you would simply subtract 4. Because the 4 plus 4 and the minus 4 undo each other. And this is a little sidebar here. If you had x squared, the square root of something equals 5, you would square both sides, because squaring a square root cancels out the square root. Hopefully you've seen both of these kind of examples. So these are inverse operations. They undo each other. And so the tangent function has an inverse operation as well. It's just not quite as special and doesn't look like a completely different thing. It's plus 4 and minus 4. That's a different operation. Square root and squared, those are opposites. But inverse tangent is just like that. Tangent to the negative 1 power, but we read it as inverse tangent. So I'm going to take the inverse tangent of both sides. Inverse tangent of the left, inverse tangent of the right. It's a little bit different from the minus 4, because minus 4 you just do to both sides, but you don't subtract 4 of something. You just, in this case, we are taking the inverse tangent of. Now when you take the inverse tangent of tangent, it frees the theta from the captivity of the tangent. And then inverse tangent of 3/4, that's a calculator question. And so above your sine and cosine and tangent, you have an inverse sine, inverse cosine, inverse tangent. So you have to hit the second button and then tangent. And we're going to do 3 over 4. So you get 36.9. So 36.9 degrees is our angle right here. Now you could have used a different one to get there as well. We could have used our 4 and our 5, but that would have used adjacent and hypotenuse. And that would have dealt with the A and H. A and H deal with the ca part. So we would say cosine of some angle is 4 over 5. And so then you would do, okay, inverse cosine of the cosine and inverse cosine of the right-hand side. And cancels out on the left. And you just get the theta. And then you do inverse cosine of 4 over 5, and you're left with 36.9 degrees. Again, no need to do it again. I just wanted to show you that you could have used a different one, the other side length that we had. You could also set up a sine equation And from there, you could just subtract to find this extra angle. 90 degrees and 36.9, subtract it, you can find the last part. There you have it. Good luck as you use different side lengths to find missing side lengths in triangles.